Okay, doing another one on this Dayton Hamvention find. Went to Dayton and about a month ago, a few weeks ago, and unpacking, and I bought this Blackcat JB-150 for a song and a dance. It didn't have a tube in it, so since we were unpacking and headed upstairs, we decided to run through it right quick. And so anyway, it's a 150 with the big 7581 or 8417, which is a 6L6 family of tube. That's a heavy duty version of the 6L6 used in the Tram D201a. And then this smaller tube is a, I believe, 6AQ5 King tube. Yep, I saw it on the writing that they used in this one. This is an earlier version of the JB-150. It's even marked on the back JB-150a. And the earlier version used a tube keying circuit, which is that tube there. And it also has a variable capacitor here for the tune cap. Whereas in the later versions, they used a transistorized keying circuit, and they used a fixed capacitor here. It wasn't tunable. There was nothing to tune, at least on the output, except that variable on the input, which is, this one does have that variable in the back on the input side. But there is one thing I found about this early version that was interesting. It looks pretty much like the other JBs. You know, it's turbocharged with the screen circuit and the negative bias. And let me get me a pointer. I use this pin for the plastic pointer. This here is the high voltage power supply caps, your bleeders right here. You know, Blackcats do have bleeders, but this resistor here goes to the halfway point of the high voltage power supply, or the center tap. And this resistor here is the turbocharger. It goes over here to the screen. The screen grid has half plate voltage, about 350 volts on the screen right here through this resistor. And then down here is the negative bias. The low voltage goes through a diode that's kind of tucked in under here. The capacitor, there's a resistor on the other side, and then there's a voltage regulating Zener diode tucked under there too, and that's the negative bias. But what's interesting on this early model is that there is nothing on this amp to cut off the screen during standby. This, or cut off the voltage or the power to the tube during standby. During standby, you know, except for drive, this has all the voltages and all the power, all the grounds going to the tube, so it will conduct some current or some power even during standby. Pretty much any other amp during standby, you cut the tube off some way. You unground the cathode, or you take off the high voltage, or you remove the power from the screen. Even Blackcat, they had many different versions of these amps. I would say, 30 or so that I've saw, where they've changed different stuff and keying circuits and biases and the way you cut off the tube. One thing that'll drive you crazy, in some Blackcats, they cut off the screen, or they cut off the turbocharger. Like I say, this resistor goes from the center tap of the high voltage straight to the tube. So that anytime the high voltage is on, which is all the time on this amp, you got the turbocharger going to that directly to the tube. What Blackcat did in some models, especially the later models, is they started using that to cut the tube off during standby. So they would send that voltage, like this resistor, to the relay over here, and have the relay only cut that power on, when the relay is keyed in, then that power would go out to the tube. They did that in later, but before they did that with the screen, what they used to use is the negative bias. They would use 2 levels of bias, like to operate. It's somewhere around 30 or 40 volts, negative volts, to put on the tube to operate the tube. So what they would do is they would have 2 levels of bias. Like they would have 80 volts or 100 volts or whatever going to the tube, negative bias, which would stop the tube from conducting or working or drawing power during standby, and that would go to that higher negative voltage, or lower, I don't know which would be the appropriate term for negative voltage, but that voltage, extra voltage, to cut off the tube would go, you know, to the relay, and then when the relay is keyed down, you would put the negative 30 on there instead of the negative 80 or negative 100 to make the tube conduct. But I said all that because what's interesting on this one is there's only 2 contacts for this relay, just in and out over here. There is no third contact in the middle here, and there's nothing again to cut off this tube at all when it's in standby. So the tube is actually it's basically class B, maybe class C on this amp, so it's not pulling a lot, but it's pulling a little bit and getting warm, you know, even in standby, the way they have this amp configured, this very early version. And by the way, while I'm in it, that's the underside of that tune cap that I said that the later ones don't have, that variable capacitor right there for the tune. Then you got your coil, and then you got your output going there. So anyway, that's the insides of this amp, and I just wanted to go through that this one here in particular has no cutoff. So hopefully we're plugged in. We're going to turn it on, let it warm up a little bit. And the other side of that, since it doesn't have anything to change the bias or cut off that tube, it uses kind of a medium negative bias, which is a little bit lower or a little bit more voltage than I would have in a regular operating, but it's a little bit higher than I would like for standby, if that makes sense, or did I say it the opposite? They used a compromise voltage for this amp, since they're only using 1 and they don't vary it. And with that compromise amp, and actually one more thing I thought of, this meter is not an output meter. This is actually an amp meter or a milliamp meter, and you can see it drawing current a little bit even in standby. Let's see if it goes down. You see when I turned it off, the voltage is off. That thing is actually drawing current or cooking a little bit even in standby, the way this thing's configured. So anyway, that's that compromised bias. It's drawing a little bit of current. If you lowered it, it would draw too much current, and if you highered it, made it too much higher, the amp wouldn't do very many watts when it was ready to use. So it's a compromise bias on this amp that I don't like. And last, we're just going to key it down with the trashy tram over there going into it. Already on the 200 watt scale here. We're going to put it on average though instead of peak. And we keyed it down. You can see the amp meter, you know, shoot up when we key it down because it's drawing more current with drive in it. And here we go with, you know, 2 or 3 watts in with the trashy tram. Basically a half a watt dead key is all this thing is doing with that compromised bias on it. Audio. If we had switchable bias, you know, we would make the dead key a little bit higher than that, but with that compromised bias, that's all I could do with it. Is that very low dead key. Audio, talking to about 30, shushing to about 35, whistling to about the same, and last we're gonna put it on peak. Audio. audio. Doing about 50 watts peak out of this thing with a that's a junky 7581 I put in there, and I don't like that bias scheme, but I'm not gonna mess around with it or change the relay or do anything with it to that. So if anybody wants this one for 50 bucks, which I think is a great price for mostly working JB12, I just don't like the operation of this one, and I'm too busy to go in there and change it around. But anyway, that's it for this early version of the Blackcat JB150, a JB150A. Bye.